Okay, so we're going to be working on proving that triangles are congruent. So we're going to build from what we started yesterday. Okay, so just like any other proof we've done, we start with a given statement and a proof statement, and we have a figure. I'm going to be using lots of different colors today. If you're a person that likes to use colors, you might need like 4 colors, maybe 5 at the most. If you want colored pencils, I've got colored pencils too. Does anybody want anything? Okay. All right, so I'm going to color code for today just so you can see what matches with what. After today, I don't always color code, and you can or not, it doesn't matter to me. So let's go ahead. Hey, Gavin. Gavin, do you need your folders? Do you need it? Here you go. I emailed you.
Yeah.
There you go.
Yep,
got it. Okay, so let's go ahead and start with our first given. Let's start with our first given. So we have angle H is congruent to angle L. Yep, this is its own color. All right, so angle H is congruent to angle L. That's given to us. Anytime we write a congruency statement, we're going to immediately mark our figure. Okay, so angle H and angle L are congruent. I'm going to leave those as red too. That way you know the red markings are associated with the red writing. Good? Okay, our next congruency statement says angle K is congruent to angle P. Angle K is congruent to angle P. That's given. Okay, so K and P are congruent, so I'm going to mark those as being congruent on my figures. Good so far? All right, let's do our next given. We have HJ is congruent to LM. So HJ is congruent to LM. Now I did put the segment markings above it on my givens. Honestly, most of the time from here on out, they don't use the segment markings and the line markings. They don't use it very often. The only time it usually comes back into play is when we're in chapter 6, which is all about circles. Because in a circle, you can have a chord named like JK. You can also have an arc named JK. So sometimes you have to distinguish between the two. So I'll let you know like when you for sure have to put them back on. Okay. All right. So that's another given, and I marked my figure already. Okay. So do you remember yesterday how I was asking you, do we have 3 congruent parts? Yes. Okay. So the reason I was asking you is I was training you to look for, do I have 3 congruency signs? I do. I have 3 parts. I literally have to see 3 congruency signs. Okay. Is it a good combination? So looking at my figures, is it an acceptable combination? Yes. What do we have? Angle, angle, side. So I can say that triangle HJK is congruent to triangle LMP because of angle, angle, side. All right, so this one was kind of nice because everything was just given to us, right? We didn't have to work very hard. But I wanted you to see kind of the process in terms of we're going to make a statement, give our reason, and then we're going to mark our figure. And we're looking for the 3 congruency signs. Then we can say why our triangles are congruent. Yes?
So we need 3 statements, like obviously not all can be given, and then we take for what we have yesterday.
Yes. Yep. Yep, that's exactly it. All right, let's look at another one here. So here's the next one. It says AB is congruent to DC, and triangle BAC is congruent to triangle DCA. So this time we only have 2 givens. All right, so let's take care of the first one. We have AB is congruent to DC. That's given. So AB and DC are congruent. My next given says that angle BAC is congruent to angle DCA. So angle BAC and DCA are congruent. Right. So do we have three congruency signs? We only have two, right? So we're going to need to find something else. Good. We know that AC has to be congruent to AC. They share that segment, right? So this is the reflexive property, which I talked about a little bit yesterday. Our book also calls it same segment. So some people like to write same segment, some people like to write reflexive property. I don't care which one you use, I'll try to say them both every time. Just be familiar with them. So same segment. We good? All right. Do I have three congruency statements? Yes, we do. Do we have a good combination? Look at my figure up here. I marked things. Do I have a good combination? Yes, what is it? Side equals side. So now I can say the triangle ABC is congruent to triangle CDA because of side angle side. All right, you try the next one. You try the next one. Start with your givens. See if you can find anything else. You can't say yeah, I think I printed it several times. Yeah. Gotcha. Do you have enough time? All right, so I have my givens up there. So I went ahead and marked those. Okay, so I only have two congruency statements. Where's my third one going to come from? we have angle, you have that angle at F, right? So these two angles here, we know are going to have to be congruent, but be careful, we just can't call it angle F. Because there's a lot of angles happening at the vertex of F, right? So we have angle DFE is congruent to angle HFG. Now remember, you can reverse these. You could have called it EFE or GFH, right? As long as F is in the middle, because it has to be a vertex. And those are called vertical angles, right? So that's the vertical angle conjecture. That's our vertical angle conjecture, right? Okay, so now we have three congruency statements. Is it an acceptable combination? Yep, what do we have? Side angle side. So I have triangle DFE is congruent to triangle HFG because of side angle side. So we have two sides, and we have the angle in between them. So it's side angle side. Okay, so before we move on to the next one, I want to kind of make a point here. So let's say it's a test day or a quiz day or whatever, and you're freaking out, you don't know how to do a proof like this. Think about how much you can do with knowing very little. You could have written 1, 2, 3, 4, 5 parts at the very least, right? There's no excuse not to write the givens. Those are literally given to you, right? Those are freebies, okay? You know how the proof has to end. If it's a triangle congruent to a triangle, you've got 5 options, right? You might be able to narrow it down a little bit. Okay, so never ever leave a proof blank, because you can get points somehow. Even, I'm telling you, like, if you have absolutely no clue, which I don't think will be the case, I'm just saying don't ever leave a proof blank. Okay? All right. All right, we are going to skip this. We're going to do this one last. I should have put it last in the notes, but I don't want to kill more trees. So we're going to come back to that one. Let's go to this one next. So go ahead and take care of your givens. Write down your givens and mark your figure. All right, how are we doing? Do you have your givens written down? Not yet. What's that? All right, so for this problem here, we only have one congruency statement so far, right? Okay, so this here, what does this symbol mean? Parallel. So AB is parallel to DC. So this is not a congruency symbol, which means we're probably going to have to draw a conclusion from this. So this is going to lead us to a congruency statement most of the time. All right, so we have our angle A congruent to angle C, and we have parallel lines. What else could you see that we could possibly use as congruent parts? DB is congruent to DB. Okay, I'm going to leave a little space for today. It truly doesn't matter, but I will leave a little space here. So DB is congruent to DB. Why is it congruent to itself? That's the reflexive property or same segment. All right. So there's 2 congruency statements. We need a third.
Wait, sorry. Yeah, AB is congruent.
You're close. You wanted the other ones.
Oh,
All right, because of my parallel lines, and I'm going to show you how to determine which ones. These two angles are going to be congruent. So because of my parallel lines, those angles are going to be congruent. Do you remember what kind of angles those are? Alternate interior angles. Good job. Alternate interior angles. So let's write it down, and then I'll talk about how to distinguish them. So angle ABD is congruent to angle BDC because of alternate interior angles. Remember, we came up with AIA as a shortcut when we were proving that there's 180 degrees in a triangle. We brought that up. It does not. It does not, but I was just doing it for color coding purposes, meaning like I know those angles are congruent because of the parallel line ones. So just for today, otherwise I would have just written it later. So no, the order does not matter there as long as your parallel comes first. All right, so to determine which angles here are the alternate interior angles, there's a little bit of a trick. What I like to do is I like to envision my parallel lines highlighted. Okay, if I highlight my parallel lines, then I highlight a transversal, it makes the letter Z. You see the letter Z? The alternate interior angles are tucked into the angles of the Z. Those are your alternate interior angles. So make a Z with your parallel lines. The angles tucked into the angles of the Z, those are the alternate interiors. Is that okay? You sure? Are you lying? Yeah. That's fair.
Wait, what?
Do you see your Z?
What if the parallel? Will the Z always be that way? Or
No.
will it be that way?
So what if it would have been like, let's say these were my parallel lines. Here's a transversal. So see the Z or the N, you want to think about it? Is the angle tucked inside?
Okay.
Is that okay?
Yeah.
All right. All right, so now, do we have three congruent statements? Yes, do we have a good combination? What do we have? We have two angles on the side, right? The side is not in between, so it's angle, angle, side. So we have triangle ABB is congruent to triangle CDB because of angle, angle, side. Is that one okay? All right, next one. Next one. Go ahead and take care of your givens, please. All right, so we have two givens here. Only one of our givens has congruencies, right? Or has that congruent statement. So do you see anything else, or can we draw a conclusion from XZ as an angle bisector? Yeah. Okay, so these two angles right here have to be congruent, right? So if XZ is an angle bisector, then WXZ and YXZ are congruent. So let's make that statement. Angle WXZ congruent to angle YXZ. Okay, so what gave it away? How did you know that those two were congruent? Because this here, right? Angle bisector, because you knew what angle bisector meant, you can make this statement. So anytime it's like a vocabulary term that kind of like clues you in what to do, you write definition of and then in our case here, it's an angle bisector. So definition of angle bisector, definition of midpoint, definition of perpendicular. Okay, so if it's a vocabulary word that you understood, that meant something, just write definition of and whatever that term was. All right, good. That's 2 congruency statements. We need a third. We don't know that for sure. Okay, now you are correct. They are, but there's a lot of things we'd have to prove first in order to draw that conclusion. Okay, so is there something else? Yes. Good. So XZ or ZX, whichever, is congruent to XZ. Why is that? Same segment or reflexive. Okay, now we have 3 congruency statements. Is it a good combination?
Yeah.
Yep, what do we have? Side angle side. So we have triangle WXZ is congruent to triangle YXZ. It's a side angle side.
So since it says it's a bisector, can't you also say WZ is congruent with ZY?
WZY.
And then,
No, because it's an angle bisector. It's cutting the angle X. It's cutting angle X in half.
would it also have to cut?
Ultimately, yes, it does. But we'll learn more about that on Monday. So there's still more logic that would need to happen in order to get to that point.
So you couldn't say it was side.
No, we cannot in this case. We cannot in this case.
Do we have to for like segments to be
You do not have to. All right, next one. This should be on the bottom right. Okay, so this time, let's go ahead and take care of our what given. We have B is the midpoint of AD and EC. We don't even have a single congruency statement to start with, right? We're going to have to draw conclusions to make all of them. Is that it, Claudia? Okay, so we recognize these 2 angles here. These are our vertical angles, right? So we know angle ABE is congruent to angle DBC because of the vertical angle conjecture. Yes. Good. We know AB and BD are congruent. And I know that why? Because you know a midpoint net, right? So AB is congruent to BD by definition of midpoint. Okay, anything else? So BE and BC. Okay, so BE is congruent to BC because, again, of definition of midpoint. Put it out of the way here. So those 2 lines, you can write them as 2 individual lines. You can write them all as 1 line. It doesn't really matter. Everybody does a little bit different. One way is not right and one way is not wrong. All right, we have 3 congruency statements. Is it a good combination? Yep. So we have angle AB or triangle ABE is congruent to triangle DBC because of what? Side angle side. Good.
So if we wrote it as AB is congruent to BD, BD is congruent to BC, BC is congruent to BE, that would also work? Do you want to come like that? I just wrote it out.
A, B, C, D, okay. B, D.
Because it
You
says,
don't know that.
because well, it says it's an endpoint both ways.
Okay, but it says, but think about this. What if I did this? That's the midpoint of both of those segments. That doesn't mean all four parts are congruent.
Yeah, okay.
Does that make sense? All right, let's go to the last one, then the one we skipped on the front. So go ahead and take care of your givens real quick. All right, do we have our givens written down? All right, so we have one congruency statement. What else can we do? I think. They're both what, saying it? Okay, so how did you know, let me back you up. How did you know they were 90 degrees? Okay, so you said the word because, right? If you're saying the word because, it needs to be a statement and a reason. Okay, so that means you drew a conclusion. So let's start with angle G and angle J are right angles. So angle G and angle J are right angles. And how did you know that? By definition of perpendicular, right? This is another one you can write in two different, you could write it twice, do it once for G, do it once for J, or you can throw it all together. Okay, so now, this is why I'm saving this one for last. Because we have right angles, we might have two options here. We could use the right angles and say they're congruent, so we could do like side angle side. But we also know if we have right angles, we have the possibility of hypotenuse leg. So this, when we have a right angle, we need to kind of step back and figure out which way we want to go with the proof. Because if we're going to say that they're congruent, then we're going to use like side angle side. If not, we got to say we have a right triangle. So are we going to use a normal one, or are we going to use HL here? We're probably going to use hypotenuse leg. Otherwise, we're going to end up with angle side side, and we're not allowed to square, right? Okay, so I need to say that triangle GKH and triangle JKH are right triangles. So in order to use hypotenuse leg, you have to say you have right triangles. So this is definition of right triangle. Okay, so we've set ourselves up to be able to use hypotenuse leg. We have our leg. We still need our hypotenuse, right? Okay, so where are we going to get our hypotenuse from? KH is congruent to KH because of we have same segment. All right, so now, do we have all the requirements for hypotenuse leg? We have two congruency statements. Did we say we have a right triangle? So you still need three parts. They're just not all congruency parts for a hypotenuse leg. Okay, so now we do. So now we can say that triangle Triangle GKH is congruent to triangle JKH because of hypotenuse layer HL. So there's a few rules to learn in terms of how things go, but they're not horribly difficult. Not the most exciting thing, but I think we did the hard part for the last 2 days in terms of figuring out all the shortcuts.
Sharper transmitted. I was a little concerned at first. Yes, I'm sharper. That's what we did. How often do you have to present the conclusion? So taking stations process. Wait, is it a communication time? How often do you have to present it? That's the entire week. No, is it like every week? It's kind of not. How much you have to communicate in communication studies? I don't know. It's like I had to turn on the and then just like a fire alarm. And then just like a fire alarm, a car alarm, so the noise can't smell it. No, that's just nice and cool. That's just nice and cool. So you're gonna track all the way to my very messy, as you can see, I just put there. What happened to you? Oh, it's not a very, it is not a because it's so long. The grapes there. Sort of a sport that is not drawing. Yeah. You give us all your money. You give us all your money. You give us all your money. Yeah. You're an antique. Yeah.